This is Christian Jules Lab 8. This is my comparator circuit with the voltage divider and the LED with the resistor coming out of the op amp. And we can see that it works like it's supposed to. So above a certain threshold, the LED is illuminated like that, and below this threshold, it turns off like that. So basically there's a point at which the LED will turn on. So this is my analysis of a non-inverting op amp circuit per exercise 1. So basically what I did is I took a node here at point A. I used Ohm's law for the current coming in, and the current going out and the current coming in, because I know there's no current from V negative. I solved for V in and V out, and then I solved the gain using the ratio of V out to V in. And after canceling out and considering that V in is just IR1, I was able to resolve it to 1 plus R2 over R1 for the gain. That's it. This is my unity gain amplifier or voltage follower circuit with the potentiometer. And there's a lot of noise, I'm not sure why, but we'll see that when I decrease in voltage, or when I decrease VN, V out and V negative follow down to a certain point around 2 volts where V negative and V out bottom out, and then I can go lower than that with VN. This is Christian Jules inverting amplifier with a gain of -10. I can vary the potentiometer, and I'll show you what it looks like on the output screen. So basically we can see that -10 gain as VN in the white there approaches about 0.8 volts. So as it goes up towards 0.7 and 0.8, we notice a change in V out. That change in the blue only goes as far as when Vn gets to approximately 1 volt. So basically there's a 0.2 volt difference in Vn, and as you can see, about a 2 volt difference from 4 to approximately 2 in V out. And it goes the other way. So as Vn increases, V out decreases. So that's where the -10 gain is. This is my analysis of the integrating op amp. It's like the other analysis in that we're looking at this node here where there's no current from the op amp going into the op amp, and so this current here is equal to that current there. IN is equal to I out. So using Ohm's law here, with the resistor, we get that Vn minus I sub 1R is equal to V negative. So we're just solving for that, the voltage right there. And looking at the current out through the capacitor, we use the equation I is equal to C dV dt, and then solving that by integrating, we can get V negative is equal to 1 over C, the integral from 0 to t of I dt plus V out. When we set these two equal to each other and solve, we get V out is equal to Vn minus IR minus the integral from 0 to t of I dt. And this is my integrating op amp with the capacitor right there. Here's the output. I put a potentiometer on even though it doesn't mention it in the lab, but we can see that as it approaches this critical value, just around 2 volts, V out goes like that, and then it settles, and then if I cross that threshold again going down, V out goes up like that at the same rate.